We'll continue with our structural patterns with the bridge pattern. And the bridge pattern is an interesting pattern, and it's going to share some similarities with some other patterns that we've seen before. The bridge pattern is for if you want to decouple the application from a feature implementation, or effectively decouple two classes, so that the two classes really don't know anything about each other, and if one of them changes, the other one doesn't have to adapt to that change. The intent is that the bridge in between those two classes will decouple them to the extent that neither one of them has to change. Now, it's kind of a bit of a perfect world, and actually in a perfect world, our classes would be so well written and encapsulated that implementation changes wouldn't affect any class that calls them. But in the real world, those changes may in fact affect other classes. So what our bridge does is it tries to isolate the impact of those changes. It also allows us to think about different types and future expansions. So for instance, we want to do some messaging in our application. And initially, we're going to implement SMS. But we know in the future, we're going to implement email and then all the other chat services and APIs. And that messaging interface is probably going to change a lot. We don't want the rest of the application to know anything about those changes. So we're going to put a bridge in between our application and the messaging service, so that effectively the application knows about messaging, but it doesn't necessarily have to adapt itself to what type of messaging service is being used. Social media is the same kind of concept. We may want to do posts to Twitter. Okay, so we can implement that easily enough, but then we want to expand and be able to post to Facebook and to other social media. And all of a sudden the interface starts to change with each one of those social networking outlets that we're choosing to post to. So again, we want to hide that from our application. The best way to do that is to put a bridge in between the two, so that when we've initially written the application, we've at least had to think about that to present a more generic interface to the application, and then the bridge will handle the details of interfacing with Twitter and Facebook and the like. We have the same kind of concept with logging. Again, we can log to files, databases, Windows, event viewers, so we have different types of logging, but we don't want the application necessarily know anything about that. We also can have different data sources. We may be pulling in data sources from web services, from a local database. Again, the application hopefully is decoupled from all of those classes, and the bridge helps enforce that. By the way, does that logging and data source stuff sound a little bit familiar? If it does, you may have seen the factory pattern lessons. And the bridge has similarities to the factory, but it's a little bit different in what it's intending to do. The factory patterns are creation patterns, so we're creating logging services and data sources. The bridge is really a bridge between classes and not a creation type of pattern. So it's slightly different, but some of the problems we're dealing with are similar. So you might guess that you might combine factory patterns and bridges together in order to isolate application code from these different kinds of features. So the idea behind a bridge is to decouple an abstraction from its implementation so that the two can vary independently. That's the definition out of the Gang of Four. What that means is the application is going to be written towards the abstraction, and the implementation is going to be written away from that, so that the actual application classes aren't talking to the specific implementation classes. There's a bridge in between them, and that in fact decouples them from each other and hopefully protects them from changes from each other. The idea is to provide an abstract class or an interface, and then feature classes will be concrete implementations of the abstract bridge class. And the abstraction class is used by the application. And please note, abstraction doesn't necessarily equal abstract class. An abstraction can actually be a concrete class in itself or implement an interface. The terms don't mean quite the same thing in this pattern, and because the words are really close, there can be some confusion there. So for our example, we're going to do a messaging feature. We're going to implement SMS or email, and those are going to be the choices for our customers. In the future, we expect that we're going to want other types of messaging. And there's all sorts of APIs for messaging apps out there, and we know that there's all sorts of work that we're going to need to do, and all of those interfaces and implementations are all different, and we're going to have to work with all of that, and we don't want the application to have all of those changes filter through it. So we create an iMessage interface for our abstraction. This is not an abstract class, it's actually an interface that's being used as the abstraction that the application is going to talk to. And that iMessage interface has a send message method. Very simple, so that's all the application needs to know about. Then there will be concrete SMS message and email message classes, and those will implement the iMessage interface. So that should have sounded a little bit familiar, similar to a factory that has an interface that's presented to the application and then a couple of underlying concrete types. But again, a factory pattern is a creational pattern, so we're talking about creating classes, whereas a bridge, classes are already somewhat assumed to be created, and we're actually talking about using them in the full implementation. Then we have a message controller class. And this is going to be an abstraction class, and it'll have that send message and set message type method. And it will decouple the iMessage and the concrete implementations from the rest of the application. So this is what's going to sit in between those two. So you can think of this as the actual bridge class, although the entire pattern is the relationship between all of these classes. So a picture hopefully covers 1,000 words. So we have our message controller class, and it's got a property of a message object, and that's actually going to have an iMessage implementation. And then it has the two methods, send message and set message type. And those are going to be used by the application. We have a little enum for message type. And as we grow, that enum will grow. Then we have the iMessage interface, and it has a send message method on it as well. Now the send message method for the message controller and the send message method for iMessage don't necessarily need to be the same signature. Message controller doesn't implement iMessage. It actually uses iMessage on that message property within it. So the send message can be completely different. And in fact, they don't have to share the same method name. They're completely different classes. And then we have SMS message and email message that implement iMessage. And of course, those send message methods do have to implement the signature of iMessage. So that's the idea behind the bridge. And I do encourage you to take a walk through the sample with me in the next lesson because that will help.